Hi boys and girls, today we're going to be modeling multiplication. Our objective for today is I will represent and solve multiplication facts by using a variety of models. Before we begin representing and solving facts, let's review some of our models. We have equal groups. So when you have a problem like 6 times 4, remember that the multiplication symbol is going to stand for groups of. So in this case, you have 6 groups of 4. So you would model it using 6 groups, and each group will have 4. So 6 groups of 4 is equal to 24. We also use repeated addition. Repeated addition is when you add the same number over and over and over again. In this case, with 6 times 4, that means you have 6 times the number 4. So 4 plus 4 plus 4 plus 4 plus 4 plus 4 would give you your 24. You are adding the number 4 6 times. We also use arrays. So arrays are arranged in rows and columns. In this case, if we have 6 times 4, that means we have 6 rows of 4. So we would model our array by doing 6 rows, and each row would have 4. We can also use a number line or skip counting. If we look at our number line, if we have 6 times 4, that means we are doing 6 jumps of 4. So we would do 1 jump of 4, another 4, another 4, another 4, another 4, and then our last final jump. We can also skip count. So if you're multiplying 6 times 4, that means you're going to skip count using the number 4 6 times. In this case, it would be 4, 8, 12, 16, 20, and 24. And finally, friends, I want to talk about the commutative property. What this tells us is that the order of the factors is not going to change our product. So in our example, we've been using 6 times 4. Well, 6 times 4 is 24. If we change the order of our factors to 4 times 6, our product will remain the same. It is still 24. Changing the order of your factors will not affect what your product is. Now that we have reviewed our models, let's go ahead and practice using all of our models to represent and solve a multiplication fact. So our job is going to be to represent 5 times 7 using equal groups, arrays, repeated addition, and a number line and skip counting. So if I have 5 times 7 and I'm going to use my equal groups, that means I'm going to have 5 groups of 7. So I would draw out my 5 groups, and each group would have 7. And then I can go ahead and figure out, well, what is my total? How much do I have? Well, if I have 7 in the first one and I add 7 more, I'm going to have 14. 7 more would give me 21. 7 more would give me 28. And then finally, 7 more would give me 35. So now I know that 5 times 7 is 35. Now, if I'm using arrays and I have 5 times 7, that means I'm going to need 5 rows of 7. And I've already done my first row. As you can see, I've added 7 to it. I'm going to need 5 rows total. So I would add another row, another one, another one, and another one. So if we count my rows, we know that there are 5 rows and each one has 7 in it. So my first one has 7, and if I add my next one, it'd be 14, then 21, 28, and finally 35. Now let's go ahead and do our repeated addition. Well, if I have 5 times 7, that means I'm going to add the number 7 5 times. So I would have 7 plus 7 plus 7 plus 7 plus 7, which would give me 35. Now let's model that on a Let's model that using skip counting. So I would start with 7, and then 14, then 21, 28, and then finally 35. I'm using my multiples of 7 to reach my total. Now I counted the number 7 5 times because we have 5 times the number 7. Now let's see how it would look on a number line. So I have my number line here, and if I have 5 times 7, that means I'm doing 5 jumps of 7. So my first jump would be 7, and then I would do a second jump of 7, a third jump of 7, a fourth jump of 7, and finally my fifth jump of 7, and that would give me my 35. So friends, we have just used all of our different types of models to represent our multiplication fact of 5 times 7. So now we know that 5 times 7 is 35. And then if we use our commutative property, we know that we can change the order of our factors. So we can have 7 times 5, but we would still have our same product of 35. So boys and girls, we just represented and solved a multiplication fact. Now it's your turn to show us how you can represent and solve multiplication facts. Please refer back to this video as many times as you need to, or look at the example provided on the next slide. Thank you, friends, and have fun representing and solving multiplication facts.